So I request everyone to be more interactive so that you can gain knowledge of basics and understanding of Kubernetes and Helm. So these are the major and one of the most important topic or tools in DevOps. So moving on to today's agenda, we'll follow this agenda. I'll just explain and give you the overview of Kubernetes and the architecture, and we'll have two hands-ons. The first hands-on is that we'll be creating our very own cluster on AWS EC2 and then deployment part. So for that, we have to need an overview of YML configuration file. So this is what we are going to follow today. So be sure you'll be interactive, and if you have any doubts you can just ping me in the chat box, or else you can just unmute yourself and ask your doubts. So do you have any understanding or knowledge of Kubernetes? Do anyone have you worked with Kubernetes tool?
Not worked with Kubernetes, but as far as I know, it's something which can deploy containerized applications.
Yes. It's actually, yeah. Yes, that's right, Diana. So okay, we'll just move. So yeah, what is Kubernetes? So as you mentioned, Kubernetes is an open source system, and it's an open source tool which will manage your deployment process and the applications. That too, it will manage the containerized application. And do you know who developed this tool? Anyone from this meeting? You can also text your answers in chat box. Like, who developed the Kubernetes tool? Okay, so basically Kubernetes is developed by Google, and they made it as an open source software so that it can be automated for deployment, scaling, and for the management of containerized applications. So containerized application is nothing but the Dockerized application. So last class, Sakshi and Mohanapriya have covered that Dockerized application, like containerizing your application part. So here we'll just learn about how to deploy it, how to create the clusters and everything. So this is what the key aspects of Kubernetes. So it has some key aspects like automated scheduling. It can schedule itself across multiple cluster or multiple environment, and scaling. So scaling up and down. When incoming traffic hits, it can scale and adjust based on the demand. And other one is the self-healing part. When one failed, it can replace it by other replica sets or replication of your application. Okay. Next thing is service discovery and load balancing. Like, it can ensure the communication between your application through the external part and everything, and it also share traffic through load balancing. Okay. And last part is the storage management. So it can mount and manage storage dynamically as needed by application. So these are the key applications of Kubernetes tool. Now, this is the important part in the Kubernetes. Like, the architecture of Kubernetes is the important part. So make sure you have an overview and basic knowledge of architecture. So with this help of the architecture only, you can proceed with your Kubernetes part. Okay. So first, the architecture will be consisting of cluster. So when you take Kubernetes, the main important thing you have to know is you need to know how to set up the cluster. The cluster configuration and installment is the foundation of Kubernetes. So how I'll just explain. I'll give the overview of it. So first, cluster have two nodes. One is the master node, and other one is the worker node. Okay. So in the cluster, in the master node, we have some components like API server, scheduler, control manager, and etcd. So these are the components of master node. So what does this API server do? It manages all the APIs and it also handles the REST API. So it acts as a front end that exposes Kubernetes API. Okay. Then scheduler. So Kubernetes is also used for deployment, right? So scheduler helps in scheduling the applications, the replica sets to the pods in the worker node. Next, control manager, like overall control and manage the. It also monitor the cluster and ensures desired state is maintained. And etcd. So etcd is like something a key value pair thing. It will store all the configuration sets and it will store all the configuration and the installment sets of cluster in it. So this is what master node's component. Moving on to the worker node. In worker node, we'll be having pods. Pods are nothing but container. You know, container are just an application which is like Docker file which has image of your application, right? And these in these pods are also called as container. So pod 1, pod 2, pod 3. So these are automatically created by us depending upon our demand. Okay. Now next coming to the Docker. So Docker, the container runtime interface. So with this help of the Docker, you can pull your images to your pod and deploy your apps. And kubelet. What does a kubelet do? So kubelet ensures whether your pods or your cluster is running or not. So kubelet is the tool which ensures whether your pod or the application is running or not. And kubeproxy, as a name defined, proxy, like it helps in networking part. So it manages with the routing and load balancing between your services and pods. So here n number of worker node can be assigned. So in this architecture, they have given worker node 1 and worker node 2. Moving on to the kubectl. So how to communicate with the cluster? We'll be having this command line interface tool that's called kubectl. So with this help of this kubectl, you can interact with your cluster. So this is the overview of architecture. Again, make sure that you have thorough knowledge in architecture, at least the basic knowledge of Kubernetes architecture, so that it will be more useful. And in the hands-on session, you'll be having a good idea of this architecture also. So cluster have two nodes. One is master node and other one is worker node. Master node have these components and worker node will be having the components. So now, what is difference between both the nodes? We have master node and we have worker node, right? So what is the difference between that? Master node, it manage overall cluster. The cluster is mixture of the master node and the worker node, but here master node will manage overall cluster. And then worker node, the actual application runs on the worker node. You will be deploying your configuration file in the master node, but your application will be running in the worker node. And the key components, as I earlier mentioned in the architecture, the key components are the server, etcd, and the scheduler part. So these are the key components in master node. And in the worker node, the kubelet container runtime interface, that is the Docker, and kubeproxy for the networking part. Okay. And yeah, these are all no need, like how the workload execution and responsibility, like how master node works, like it controls the cluster worldwide and health monitoring. Here it executes the workload. Here in the work node, it will be fully only for the pods, but in the master node it also include cluster. So that's what the difference. And communication part, as I mentioned, we'll be using this command line interface tool, kubectl. In the worker node, from the master, we'll communicate with the worker node. So that is what about master node and the worker node and overview of cluster. So this is the architecture. Make sure you have a good understanding and idea of cluster. If you have any doubts in it, you can just post me your queries in the message box. So until this, you are clear? Anyone? Okay, Krishna. Any others? Okay. So now we'll move on into the first hands-on. So in this hands-on, we'll just create our very own cluster in AWS EC2. So we'll just follow these steps. Okay. So this hands-on is about creating a cluster in your AWS EC2. Okay. So here we'll launch EC2. And in the OS, the operating system, I'll be selecting Ubuntu as my operating system. Instance types. For creating a cluster, you must have two CPU, like the medium type. Oh, yeah. The requirement is 2 CPU and 4 GB RAM is mandatory to install your cluster. So actually, this is not free eligible, but comparatively it's low, like it's on demand pricing used by her only. So with I think within half an hour you can proceed this hands on. So make sure you try it out. At the end of the session, I'll be sharing the article which I have been written. So instant type, we have to choose t2.micro. And key pair, you can create your new key pair. So I just created already, so I'm just using it. And network setting, I think you're good at network setting, like ensure auto assign IP is enabled. And this is what the configuration of my instance. Here I'm going to launch two instances. One is for master node and another one is for worker node. So now my instance are running. I'll just rename this as worker node. Okay. Now we have an option in EC2, like we can connect and establish our connection, right? So first I'm going to connect my master node. So this is the EC2 connect. I'll just connect. Similarly, we have to connect the worker node also. So here I have used only one worker node. In the architecture, you have saw two worker node, but for today's session, I'm just using one worker node. I'll just connect. So this is my master node and this is my worker node. Okay, now we are good to go. Now we will start the hands-on session. So both of my nodes are established. Like I have established the connection. So first major step, I need to log in as a root user. So for that, I'll be using sudo su. So now I have logged in as my root user. Similarly, simultaneously, I need to proceed it on my worker node also. Sudo su. Okay. Now, after logging into my root user, I have to get the updates. So I'll just type apt get update. You have to follow it in the worker node also. Okay, now updation is completed in both the nodes. Now we'll start to install all the initial things. So yeah, so root user is completed and update is completed. Now we have to install this HTTP. Why? Because master node and worker node communicate with REST API. They don't have HTTP. So we'll just install this HTTP command. So you have to install both in the worker node as well as master node. So first I'm installing in my master node. Simultaneously I have to install in my worker node also. Yeah, so now HTTP connection is good and it's installed. Next, so these are the prerequisites we have installed properly. Next, we can move on with the installation of containers and such things. So first, for installing Docker, I have this command apt install docker.io-y. So this is the command to install Docker. This Docker should be installed in the worker node too. So I'm just installing. Okay, so Docker is installed in my master node. Now Docker is installed in my worker node too. To check whether Docker is properly installed, we have to type Docker version. So Docker version, I can see 24.0.7. Check in the worker node also. It's properly installed. Now installation part is over. Now we have to start our Docker. So for that, we'll be using command like systemctl start Docker. So with this command, my Docker will start. So the same command I need to give in the worker node too. Systemctl start Docker. Now I have to enable my Docker too. So for that, I'll just use the same command, but not start, it's enable. Systemctl enable Docker. You have to give in both worker node and master node. Systemctl enable Docker. Now Docker is ready to use. Next step, so we have done all these steps, like we have installed Docker, we have checked the Docker version, and we have started and enabled the Docker. Next step is to install the GPG key. So GPG, an open GPG key, so which will be installed for security purpose. So our configuration and permission files will be more secure. So we'll be installing this GPG key for our cluster. So you have to install in both master node and worker node. Yeah. So now GPG is also set. So now your cluster is quite more secure. Now I have to create an repo. So for creating an repo, for creating an editing repo, nano files are used. So I'll just give this path like nano file path, and I'll just go to this path and I'll just paste all those thing like HTTP thing, Kubernetes thing in this file. So these are available in official Kubernetes documentation itself. So I'm just going to create one repo for Kubernetes and I'm going to install all those Kubernetes components in this. So Control X, Y, enter to exit. Similarly, I have to do it in the worker node too. So nano file is used for editing purpose. It's simpler version. I'll create this repo, Kubernetes repo, and install my Kubernetes main, like manifest file. Manifest file details are stored here. Control X, Y, and enter to exit. Now it's good to go. So initial process is completed. Now we'll install our KubeADM. So I mean the Kubernetes components. So here in this cluster setting up, I'll be using KubeADM. It's a tool that's helpful for installing and managing the Kubernetes components. Okay, so you can find these commands in official Kubernetes documentation. If you type KubeADM installation, it will be directed you to these Kubernetes official documentation. So this is official Kubernetes documentation installing KubeADM. You can check with the installation here. So uh, we have selected operating system as Ubuntu, so it's Debian based. If you have selected Amazon Linux or any other, you can try it with Red Hat distribution. So here, this is what I have been in. This is what I have copied and pasted in my notepad. So I have to copy all these commands and I'm going to paste it in my master node as well as in my worker node. So I just copied all the commands. I have to install it my worker node too. So I'll just paste it here. Okay. Now in my master node, my kubelet component, KubeADM component, and kubectl component are set on hold. Like it has been successfully installed in the master node. Now in the worker node also, my all the components of Kubernetes is set. Now this is the crucial step in the master node you have to do. Until now, we have copy paste everything simultaneously in master node as well as in the worker node. Now I'll just enable this kubelet service. So I'll just use this command. How we enable the Docker, I'm going to enable the kubelet service also. Now I'll just enable kubelet, and in the worker node also I'll enable. Now I need to initiate my KubeADM. KubeADM is a tool. So I'll just initiate my KubeADM. The initialization is the bootstrap process. So here, only in the master node, I have to initialize my KubeADM, not in the worker node. So only in the master node, I'm going to give KubeADM init. So this command you should give only in the master node, not in the worker node. I'll just initiate my KubeADM. So that with the help of this, all the configuration files, manifest files of Kubernetes, certificates of Kubernetes will be installed with this initiate file. So you can see all the manifest folder and the certificate, bootstrap token, everything is initialized. And now you can see your Kubernetes control plane as initialized successfully. Okay. Now it directs you to start using your cluster. You need to follow the regular steps. Like you have to copy paste this thing. You have to just copy and paste. So these kube init and the copy pasting should be done only in the master node. Now I've just created a directory and I just configured some configuration file are added to my directory and everything. Alternatively, I'm a root user, so I need to copy paste this command too. So I paste. Okay. So as I mentioned in the architecture part, cluster is set of master node and worker node. So now I have to join my worker node with this master node. Okay. So for joining thing, they have given me the command. After successful initialization, I'll be getting this KubeADM join command. This command should be copied and pasted in the worker node to join my worker node with the master node. So I'll copy this join command. And I'll go to the worker node and I'll paste. So now you can see some fluctuations. This is why, because at the time of launching our instance, in the same configuration, we have launched the two instance, right? So I need to check the security group of the worker node. So go to your worker node, click security group. Now I'm giving some inbound traffic, right, to my worker node. So I need to edit my inbound rules. So here I'll just edit my inbound rules because I'm just initiating like joining command. So I'll just add all traffic anywhere. I'll just save. Okay, now it's saved. So once I have edited my inbound rule, you can see that my node has joined to the cluster successfully. Okay. Now, if I type in the master node, if I type kubectl, so kubectl is the command line interface tool, right, to communicate with my cluster. Now I'm going to communicate with my cluster. Kubectl get my nodes. So it should be showing the both the worker plane. So worker plane is this, that's the master and the worker node. So master node and the worker node are created but not in the ready state. This is why, because we didn't install any networking tools. So to communicate the nodes, we have to install an networking tool. So here I'll be using Fennel. So Fennel is one of the networking tool which is used to communicate between the nodes. You can also go with the alternative thing like Calico and some other thing also you can try. So here I'm just installing fennel with my kubectl command. Okay, so I'll just paste it in my master node. Now if I check whether now if I communicate with my cluster with the same command like kubectl get nodes, it should show me the status as ready. Yes, so now my clusters are ready, my worker node and my master node are ready. So here with this step you have created your own cluster in the Amazon EC2. So with like you can just practice till creating the cluster in EC2 as it's not free eligible, and this is what this is how you will be creating your cluster. So I'll just repeat these steps. So first what we have did, first we have created two instance and we have launched two instance. Here I have just taken Ubuntu as my OS, and then I have just connected with the EC2 Connect both the nodes, and I have logged into the root user, and I'll get my update. So I'll just type apt get update. So I just got every update of my operating system, and install HTTPS because master node and the worker node will communicate through REST API, but I need HTTP. So I've just installed my HTTP also, and then I've just proceeded with installing my Docker and starting my Docker, enabling my Docker, starting my Docker, enabling my Docker, and I've installed the GPG key, Open GPG key for security purpose. And I've created one nano file that is a repo. I'll just created Kubernetes repo, and I just install the manifest configuration command in that repo. Again, I'll just updated my OS now. So with the help of QADM, I'll just install all these components. So this commands are taken from official Kubernetes website, and I'll just paste it. Once I've completed my installation of all the components until the kubelet set on hold, kubeadium set on hold, kubectl set on hold in both the master node and the worker node, and I'll enable the kubelet service in both the master node and worker node. And the most important thing, kubeadium init should be given only in the master node. After the kube init, it will be showing you your successfully initialized your control plane like your master node, and it will be showing you the it will be giving you the commands to copy and paste to start your cluster, to use your cluster. So you just copy and paste, and join command at last you have to give it to the worker node to join your master node and worker node. And for networking purpose, I have installed networking tool Fennel, and then at last you will be successfully creating your cluster. So this is how you create your cluster. Even you can do this in your VM or any other OS also. So here I have just used Ubuntu so that I'll be doing sudo, but if you go with Linux or some other thing, you will be the commands will be different. So now so until this, I have just given an overview and the foundation of Kubernetes, the creating the cluster and how to interact with it. So next we'll see about the configuration files. Only two will see. So within 10 minutes, my session will getting to over. So I'll just show you a demo how deployment will work with Kubernetes, like deployment of application, how does it works. So this is how we have a configuration file. So we'll be using YML configuration file, yet another markup language file. Okay. So here we'll be having some format for this YML configuration file. So it's actually used to define and manage the state of your resource. Resource are nothing but your application. So here it will be managing your state of your application. So deployment part, as you all know, deployment of your application, like we have to ensure the correct number of pods are running and the replica sets. So that should be mentioned in the desired state. And in the service YAML, to expose our application externally or within the cluster, we'll be using this service file. So I'll just show you an hands-on of it. So for this hands-on, I'm just going to an online playground, Killer Coda, in which you'll be having your online playground with the cluster ready, both the worker node and the master node. So for hands-on session in the Kubernetes, you can try it in the Killer Coda platform, because EC2 T2.medium is actually not free eligible. So alternative way, you can try it here itself, but you can't create cluster in it. It has ready-made cluster, like 2 nodes and ready-made cluster created with it. So you'll be having an 4 GB node. Here also they have created KubeADM cluster with 2 GB nodes. So until that, we'll just see how YML file looks like. So this is how YML file looks like. First, it will be having the version of your app, like apps/vi. So you'll be having this API version, and kind is it defines the state of your resource. So here, my state of my resource is deployment, and we'll be having the metadata labels like name of your app and again labels everything. And here specification, this specification is for your replica sets. How much replica sets? Here I just gave 2 replica sets. And again, I'm just attaching with the app notepad, notes app, and template everything. So these are the specifications I'm giving for my replica set. And again, I'm just giving for my Docker thing. So containers, name of my container, and image. So this image is pulled from the Docker hub. So you can see you'll be having an Docker hub registry. So you can just take your tags, or you can just copy those tags and you can paste it in here. So the image is pasted over here. And resource request CPU. So these are all a common thing. And ports, you have to use container ports, because for local host we'll be using port 3000. So I'll be just using this. So this is for deployment purpose. So deployment YML configuration, it will be having first, it will be having your kind thing, that's to ensure the state of your resource, and we'll be having specification for replicas, and then we'll be having specification for your containers. But in the service file, you can see in the service file, we'll just have the specification of your app. So these until this select or it will be having your specification for your app, and then you'll be assigning your ports like the protocol, TCP protocol, and type load balancer. So you can also give node port, so that it can generate you a node port ID, so that you can expose your application externally. So this is how YML file looks like. Now we'll just deploy this application in my cluster. So until this, we have created in the EC2 machine, right? So we have created our very own cluster and we made it the status as ready in our EC2 thing. So now I have to write my Vim file. So Vim file in YML configuration file uses Vim Vim command to write their configuration file. So I'll just use Vim app.yml. So here I'll just copy my YML file configurations. Just paste. So this is how my configuration file of my app looks like. To exit, we have to do :wq exclamatory. Now I have to apply this. For apply, kubectl apply my file. So -f is file. My file name is app.yml. So kubectl is the command line interface to interact with your cluster, and just applying my file. My file name is app.yml. Now my deployment service is created and my service file is also created. Okay. Have to check whether my application is running or not. I'll just type kubectl get ports. So as mentioned you in the architecture part, ports are nothing but your containers. So in the replica set of my configuration file, I gave 2 replicas. So now the application, 2 applications should be running. Yes, 2 application is running. And kubectl get deployment. You'll be having your node app deployment. So my node app is successfully deployed over here. Now let me check whether if I change my Vim file, that my configuration file, if I get the same if I'll just check. If I change my replica sets, I'll just get whatever the replica sets I'm mentioning, the replica's number I'm mentioning or not. So for that, I'll just go to Vim app.yml. So here, so in replica sets, in replicas, I'll be giving as 4. And again, I'll apply this. So now my deployment is configured. Now if I check kubectl get ports, it should show 4 application running. Yes, so here 4 of my application are running. So this is how you create your application and deploy your application. Now to expose this application, now I have to see my application. What I'm going to do, we have service configuration file, right? So in the service configuration file, we have specified the ports. So for that, kubectl get service or get svc, you'll get all your cluster, the type of the service and the cluster IP and external IP and the ports that I have been mentioned. So this is my cluster IP of my application and this is my port for my application. Now I'll just copy this port 32511. Just copy and I'll go to traffic and ports. So in the traffic and ports, you can just paste your port number and you can click on access. So now you can see your application is successfully deployed. So if I test this, yes, so my application is successfully deployed. So this is what about Kubernetes. So if you have any doubt, can you can ask me. I'll just send you the article which I have made. So you can just refer this and you can create your own cluster on your EC2. You can check with the description, the message box. I've just sent you the article which I've made, like how to create your cluster in EC2. So you can refer that and you can try on your own. So do you have any doubts regarding Kubernetes so that I can help you out? Do you have any questions? Funnel is the network tool, Krishna. So networking tool, I've just used Funnel. We also have alternative tools like Calico, such kind of things. So how Docker is used for containerization, Funnel is used for networking too. Any other questions? You can just drop your questions in the message box also. No questions? Okay, I think Jenna, you can take over the session.
Thank you, Arthi. Hi guys, I'm Janarthanan, and today let's start our class in Helm. Anybody does it, any idea about what the software Helm called? Anybody? Can someone reply in the chat box? Anyone? Okay, then let's start fresh. Okay, today in this class, let's start by talking about the open source software called Helm. Okay, now Arthi has done with Kubernetes cluster. So, Helm is a software which is used to actively manage and deploy Kubernetes clusters with ease. So, obviously, we are more interested in AWS functions. That is like AWS EKS. EKS, as you know, you guys know that EKS is also used for Kubernetes clusters. But EKS is a little different from Helm. Like if you ask me what are the differences is EKS is managed Kubernetes service. The core concept of is provisioning, networking, scaling, and security of Kubernetes cluster. But the software which I'm going to start on today is about like it helps you to actively manage the Kubernetes cluster, which Arthi has created now and shown hands-on. So let me share my screen now. So I will present the PowerPoint. So yeah, guys, like Helm is a package manager for Kubernetes. Like the Kubernetes cluster, which is created or which you need to manage, is very easily managed in Helm. Helm is an open source software. I have a hands-on of deploying a Nginx software in Helm, like creating a Kubernetes cluster with a Kubernetes playground. Let's watch about that later. So let's start with simple concepts in Helm, like charts. I know we have started in Docker. So Docker is there is also images. The same way in Helm we call it as charts. Charts are the same. Charts are the same definition of the concepts of images. Like charts have the basic images which were or which we use to deploy the Kubernetes cluster. Charts are the same things, and we need repositories to put these charts on. So repositories are the main thing where we deploy the charts. So repositories are also there. Values are the values which you input inside the repositories or charts. So actually, if anybody asks me why are we learning Helm concepts now, let me say, like, if you are having a Kubernetes cluster, like not one single one, Arthi deployed a single Kubernetes cluster. Let's say we have multiple Kubernetes cluster, and we needed to deploy very easily, or we can't, like, from scratch we can't create a Kubernetes cluster without any source. So also, while creating from start, Kubernetes cluster only accepts two formats. Basically, the YAML format. I think you guys know what YAML format is. While creating a YAML format, we may get more errors, human-made errors because of the syntax, or we may not be able to organize it properly. But when we use Helm, there is always pre-available charts, so we can use it, and we can also it also gives you values. Basically, it reduces your work pressure to and half. So that is why I'm trying to give you a proper introduction with Helm concepts. So today we will not, like, I will not go through the hands-on with installation, but we will do with the Kubernetes playground where there is already a Kubernetes cluster installed. Okay, so anybody have any doubts until now? Guys, I want you to stop the session. If you have any doubts, you can just ask me. Is it okay? So yeah. So now installing the Helm, always, as you can know, every open source software has a documentation for it. So installing a Helm is not a big deal because we have a uh, pre-made code for it. And just I have the code here in my notepad. Let me show it. So these are the codes which we are going to use for now. These are the codes which we are going to use for now. This is the code which is going to be used to install the Helm. Okay, Helm is a software which is, like, to say, which is recently improvising their software. So if you are a Helm user already, has somebody used Helm already, or have any idea about Helm already? Have used Helm 2 or Helm before versions of Helm? Anyone? Nobody, I guess. Everyone are new with Helm concepts. Can anyone answer, please? Yeah. I think Krishna is the only one who's active in the session. Does anyone else can answer? Okay. Yeah, Helm is a new concept. Helm is also used for basically DevOps purposes to manage the Kubernetes cluster. Helm is mainly used for Kubernetes. Helm is a software which is hell bent only on Kubernetes. So for using Helm, you need a proper Kubernetes cluster installed in your local device, or we can use the playgrounds. As Arthi used, we will use some playgrounds now. Okay. So let me start with the installation command. A minute, I'll stop sharing. I'll get the link now. So let me present my screen now. So I got the link. So this is the one. This is the playground which we are going to be using now. Okay. So now this playground will give you free sessions for 1 hour. Now let me log in. I have already tested this, so I may have limited time in showing you, but I will be as fast as I can just to install a simple nginx command and show you how it works. So I'm going to click on the playground now, and I'm going to give Kubernetes playgrounds. So just so yeah, as you can see, the initializing Kubernetes is done. So let me start it. Okay. Yeah. Now let's start with installing the Helm. Okay. So this is the command which we are going to type in first in our. These things are already available in documentation, Helm documentation. I'll show you now. So as you can see, there is Helm documentation. You can, if you guys have any doubt, you can just refer this documentation. The documentation is pretty sleek and it has everything you need to know about Helm and the migration from V2 to V3. V2, as you can see, it's version 2 to version 3. As I say, Helm is like a software which is established right now, so they are working on their versions itself. So from V2 to V3, which was changed maybe 2 or 3 years ago. So I asked anyone have worked before. So let's continue with it. So now Helm installed. So inside our local, the Helm is installed. Let's just check it again. Yeah, the as you can see, the version is 3.31.61, the same as the version which is mentioned in the website. So it is the best version which we could get right now. So now let's start with the further commands. So first let me create my nginx command. So now I have created my nginx command. Just what the POC is about, just creating an nginx. I'm just pulling the image and I'm going to show it on the web portal. That's it. Nothing else. Just a simple POC. It may take like 10 to 15 minutes. Now, which I created, I'm installing it. Okay, now I have installed my nginx. Okay, just now let me check what are the Kubernetes pods that are available. So for it, this is the code. So as you can see, I have created my nginx and it is already running in a Kubernetes cluster now. So now let me correct it. Actually, what will happen is all the functions which we are creating in Helm will be running on a clustered IP that only it can be accessed from the inside. Now what we are going to do is, so to see the output through the ports, actually it works through the ports. I think everybody has a basic idea about ports here. Does anyone doesn't know what a port mean? Like 8080 or something like that? So, okay, I think everybody has a basic idea about it. Let me continue with it. So now let's let's just check what are the values inside my nginx. Okay, so let me show it right now. So this is the code which will show me the values inside in a YAML format inside my nginx software which is running right now. As you can see, this is the format, basic format. This is where I'm going to change the code now. The changing I will do. See, as you can see, type is clustered IP. Clustered IP is nothing in the sense it can be accessed only from the inside. That is only from the helm. No output can be viewed here. So we will be changing this type to node port. That is, we are linking it to a particular node, not as specified. It will be automatically deployed to that port, and we will check the port from here. Okay. So this is the format. Just I want you guys to just view it. So this is how your nginx values will be looking. So now let's edit it. Okay. So as you can see now, I can edit the commands here, but I got out of the command prompt. I should go back to it before I can deploy. As you can see, it is same as image. Like if we in a Docker, same process as Docker. If you are creating an image, we should install the image. Then if you are making any changes to an image, we should upgrade it later in the Docker. So it automatically doesn't get deployed. So we should be deploying it again because we are doing in a CLI. So I will be editing in this, and I will be upgrading my nginx in the next command. So the changes here will get deployed. Okay. So as I mentioned earlier, here I'm going to change it. This type, I'm going to change this to node port. So that's it. Just a simple change, nothing else. So now I am going back. Now I'm back to the CLI. Now let's check whether my things have changed or not. Okay. First, let me deploy it. So I'm going to upgrade my nginx image now. So as you can see, Helm upgrade command will upgrade the changes to the image which I made. I just made the changes in the port. I changed from clustered IP to node port because clustered IP we can only access from inside. We can't see any output or the image which is being created. Now I'm just going to view the image, okay, because I'm going to get a port right now to view it. So let me, now it is upgraded. Now let's check, okay. So as you can see, it is changed, and now the port is here. Now what I should do is I'm going to go here. I'm going to copy this. Okay. As you can see, now my nginx command is visible here. If you see this web page, so we we can display the nginx command here. But if it is in clustered IP, as I said before, you can't you can't visible, because the clustered IP is only accessible. If you want any doubt in the clustered IP or anything, you can check the Kubernetes documentations also. So, what is the meaning of clustered IP? As I said, clustered IP is cluster of many IP addresses. So, you won't get a specific port to displaying the output later. So, what I just did is I just changed the IP from clustered IP to node port. That is, I want to view what the image which I'm creating and installing in the Helm. So now I have created and installed a Nginx, and I'm showing the output here, and the port which I'm using is shown here. So Helm is basically running any software in a Kubernetes cluster. Only we can use Kubernetes cluster on Helm, nothing else. No, nothing like we can't run a software without a Kubernetes cluster. Helm is only possible with Kubernetes. So, guys, do you have any doubts? Anyone, do you have any doubts with the concepts or anything like that? So, okay, let me present my screen again. So now I have did my hands-on. Let's just see. Okay. Now the Nginx software which I downloaded already had the charts inside. Just I pull the chart and I just installed it. That's it. So helm install command helm install command will install the Nginx software which is already present inside the repo which is present in Helm. Okay. So as I mentioned, upgrade commands is used for updating the existing or the edited thing which I did now. So as you can see, this is the way that these things work. So this is how you will if you are creating a chart. Basically, if you are on one, you are creating a chart. Helm release will help you to release the chart inside the repo which is already there. Okay, so but release name should be unique name. It should not be available in any other things, just like Docker, because of the problem of we can access the two things at the same time. So unique name should be given. So basically, that's all about Helm. Anybody have any doubts? Yeah, it monitors Kubernetes. Like now, I have pulled a Nginx thing from the Helm repo. If you chart is something like the Docker images, there is a base image inside it. Just we can pull it and we can maintain our software in it. Like if I want to in Docker, we basically get the Ubuntu image, right? The same way I got the Nginx image from the Helm repo and I just used it. The same way the chart works. The chart is also the same way. Chart gives a basic underlying structure for creating a structure over it. So you don't have to provision from first. It already is half provision. You have to just edit it according to your needs. And does it monitor Kubernetes? Of course, it monitors Kubernetes. Not Kubernetes as a Kubernetes cluster. It monitors a Kubernetes cluster. Anything else? If you guys have any doubt in commands or anything else, okay, I think that's it. Okay, thank you.
Jana, are you done?
I'm done. Yeah.
Yeah, okay. Can everyone turn on the cameras for the group picture? Just a minute. Guys, I think we can conclude the session here. Is that okay? Thank you, guys. Thank you for attending.